Hello viewers, this is Josephine. You're welcome to the channel. Today we are going to look at conversion of a galvanometer to a voltmeter. Previously we discussed how we can convert a galvanometer that was already designed to measure in milliamperes to start measuring in amperes. So we're able to understand that. So if you don't know how to do that, you can check up my previous video to learn more. Now today we're going to look at how we can convert a galvanometer to a voltmeter. Stay tuned. So let's explain what we have on the board. Conversion of a galvanometer to a voltmeter. A galvanometer used for measuring very small currents can be converted to a voltmeter by connecting a high resistance, very important, or a multiplier in series with the galvanometer. What is it trying to tell us? This is a multiplier. This is a galvanometer. When you connect the two of them in series, that is in a straight line, it means it can now be converted to a voltmeter. Okay, all right. But there's something I want you to know, that because they are connected in series, the same current flows. Any current that is measured by the galvanometer is the same current measured with what? Multiplier. Is that okay? All right. So look at this PD. The total PD here is equal to the PD across the multiplier plus the PD across the galvanometer. Is that okay? Alright, so let's expatiate this diagram so you can understand how to relate these things together. Stay tuned. Looking at the diagram we have this galvanometer, we have the multiplier, they are all connected in series. So how can we look at what we have? We can first start with PD. You already know from Ohm's law, okay, that PD is equal to current and resistance. But then, because they are connected in series, we can say that the PD, total PD is equal to PD across multiplier plus what? PD across galvanometer, right? But from Ohm's law, sorry, from Ohm's law, V is equal to what? IR, okay? So the total PD is equals to IM RM plus IG RG. Is that okay? Then I said earlier that the same current flows. Any current that is measured in this galvanometer is also recorded in the what? In the multiplier. So I can also say that IG is equal to what? I what? M. So therefore, my total PD is equals to IG RM plus IG RG, and we are looking for the resistance of the multiplier, okay, that will enable this galvanometer to convert to a voltmeter. So let's look at an example to see how we can apply this formula. Stay tuned. So let's look at this example. A moving coil meter with an internal resistance of 100 ohms has a full scale deflection when a current of 10 milliamperes flows through it. What value of resistance would convert it to read 10 volts at full scale deflection? Alright, for us to do that, we have to state all our parameters given. Okay, so we are given an internal resistance of the galvanometer, that is Rg, to be 100 watts ohms. Okay, and the current flowing through it is 10 milliamperes. Remember that milli is 0.001. Okay, so we say this is 10 times 0.001. We have to convert it because you cannot leave the current in milliamperes. Alright, or rather because you're looking for some other thing and not current of the galvanometer. So we have, this is multiply, we have 0.01 amperes. Okay, then remember that the same current flowing through the galvanometer is the same that flows through the multiplier, so it's the same thing as 0.01 amperes. Okay, so how do we convert what resistance? We're looking for resistance of the multiplier. To convert it, a PD of 10 volts. So the PD across the circuit is 10 what? Volts. Okay, so if you remember the formula, which we say that the total PD is equals to PD across multiplier plus PD across what? Galvanometer. So I will say PD, total PD is equals to IMRM plus IGRG. So what's my total PD? I have 10 is equals to, sorry, my IM is the same thing as current of the galvanometer. Okay, I have 0.01, okay, RM plus 0.01, okay, times resistance of what? 100. All right, so what do we have? I will have this is what? 10 is equals to 0.01 Rm plus 0.01 times 100 is going to give me what? 1. Okay, I have 1. Then I'll take this one to the other side. So I have 10 minus 1 is equals to 0.01 Rm. Okay, so 10 minus 1 is going to give me 9 is equals to 0.01 Rm. Beautiful. Because I'm looking for the resistance of what? The multiplier. I'll divide both sides by the coefficient of Rm, which is 0.01, 0.01. Okay, so my Rm is equals to 9 over 0.01. With the help of your calculator, when you divide it, it's going to give you 900 ohms. It's going to give you 900 ohms. Okay, so we can see how we solved it by setting our parameters and doing our conversions. Then we must not forget that the same current that flows through the multiplier flows through the galvanometer. Is that okay? So they are equal. Now we are looking for the resistance of the multiplier that can help this galvanometer to be converted to a voltmeter. So once we put in what we have, we are certainly going to get our what? Answer. I hope this video was helpful. Please, if you are joining us for the first time, subscribe to this channel for more educative videos, because we'll be sending videos like this every day to help you eliminate the phobia you have in understanding physics. I will put up an assignment. You have to solve it and drop your answer in the comment section. The more you solve, the more you learn physics better. See you next time in my next class. Bye.